The image you're seeing on the screen is the first actual image of a black hole ever taken in the history of humankind. How we went from denying the concept and possibility of black holes to eventually capturing an image of it and seeing it with our own eyes. Let's explore. It was 1783 when an English country parson named John Michell introduced the concept of black hole. One of the most brilliant yet virtually unknown scientists of his time. He was a priest by day and astronomer by night, a classic figure of early science, and he came up with the idea of an object so dense that light couldn't escape it. He called these objects dark stars. The idea was based on Newton's law of gravity and escape velocity. He simply asked, what if a star had so much mass that nothing could escape? When Michell conceived of this in 1783, very few scientists in the world were mentally equipped to understand what he was talking about. So, the concept sank into complete obscurity and had to be rediscovered in the 20th century. A French mathematician named Pierre-Simon Laplace independently published the same idea in 1798, but again, nobody took it seriously. Then, in the 20th century, Albert Einstein first predicted black holes in 1916 through his general theory of relativity. Shortly after Einstein published his famous field equations in 1915, stating how the geometry of the universe is shaped by matter and energy. Karl Schwarzschild, a German physicist and astronomer, then an active soldier fighting in World War I, published the first exact solution to those equations. He identified the Schwarzschild radius, the point at which a star would form, what we now call a black hole, though he wrongly believed this to be just a mathematical curiosity with no real-world relevance. Schwarzschild didn't even live to see his papers in print. Einstein was aware of what he'd done, but very few others would be, until 1939. Einstein himself initially denied the possibility of black holes, even though they were a genuine implication of Schwarzschild's math, derived from Einstein's own equations. In October 1939, Einstein declared, "The essential result of this investigation is a clear understanding as to why the Schwarzschild singularities do not exist in physical reality." And he was wrong. That same year, Robert Oppenheimer, that atomic bomb guy, and his student Hartland Snyder published a paper proving that black holes should really exist in space as a result of collapsing stars. Oppenheimer and Snyder showed that the Schwarzschild radius defines an event horizon, a point of no return where nothing, not even light, can escape. The term black hole was coined in 1967 by American astronomer John Wheeler. Wheeler had reanalyzed Oppenheimer's work at Princeton and, initially skeptical, eventually became the greatest enthusiast for the idea. The first object widely accepted as a black hole is Cygnus X-1, an X-ray source in the constellation Cygnus. Since X-rays don't penetrate Earth's atmosphere, it was discovered using a rocket, launched to the edge of space in 1964. In 1971, British astronomers Louise Webster and Paul Murden and independently student Thomas Bolton announced the discovery of a massive but invisible object orbiting a blue star over 6,000 light-years away, now regarded as the first confirmed black hole. The most compelling physical proof came in 2015, when LIGO detected gravitational waves, ripples in space-time produced by two stellar-mass black holes merging in deep space. Then, on April 10, 2019, the Event Horizon Telescope released humanity's first actual image of a black hole, the supermassive one, at the center of galaxy M87, about 55 million light-years away. The image showed a ring-like structure with a dark central region, the black hole's shadow, caused by the gravitational bending and capture of light by the event horizon.